No, not this. Yeah, not this part because.
What? You say I don't need to record it?
We cannot hear you, Mr. Sam.
Sam, you need to unmute your mic.
Okay. All right. So this is for Tech 1. As you can see, we need now this first set of 10 need to all the assignment at the end of this March need to be turned in. So the first 10, and then the next set of 10 will be due by the end of April. And then another set of 10 will be due at the end of May. Okay, so total approximately about 30 assignments that be assigned to you, and those need to be turned in. So at this first 10, so you're gonna look through your name. The one that highlighted in yellow are the brand new student this semester, okay? And these are the assignment that I was able to retrieve from the server. So if you think you'll turn in something that is turned in, but I don't, you don't see your name, you don't get credit for it, let me know, and so I can take a look and make sure, okay? So as you can see, these are the names. Okay. All right, Tech 1. Okay, on the assignment number 8, we have people that turn in that fail. Now, assignment 8, there's 2 parts. Okay, let me go ahead and go to the website. Assignment 8, there's 2 parts to it. So assignment 8 is the diode. Okay. Enable. Okay, so assignment 8, you have this, when you open up, you will get into this main page. And then after that, you have to get, there's 2 parts to it. There's a quiz part, and on this lower bottom said problem. So you click on that page, and then this here, you have to do this calculation here, okay? That's why people turn in. I see they only complete on the quiz part, but did not do the problem part. So I know that for Tim, Tim was able to turn in, but only did the quiz part, didn't do the problem part. Same thing with Amir. Amir, you did the same thing. You did the quiz part, was able to pass, but you didn't do the problem, the second part of that. And same thing with Ryan. Okay. And also for Ryan, you have on the assignment 10. I think you got all of them right except the last question. Okay, so that's why it's showing it fail on the status. Okay, so that's pretty much up to date. And then we have a couple of students already attempted the software program, the e-calculation. Now we got for Jose, look like you got the NPN divider. That was you have one that is from the website and the one from the handout. So the one on the handout is for you to practice. So you got the one in here, the NPN e-calculation one. Okay, so this is for you to practice on, but the one that you have to do over here on the assignment, that is what is due for that you have to turn in. So
I actually turned in all of them. Can you check if I don't know if you were able to verify the others?
I was yeah, like I said, all the other one now the other one is unopened and not unopened and unopened. Okay. So we got the e-calculation, the PNPs, common emitter and common collector. I was not able to open that, and so here it's from the web. Okay, so here so.
But I sent they're all text files. So I'm surprised that you were not able to open them.
No, when you turn it in, there's special things that have to do with the protocol for the when you upload it here. When you put the C++ right here, it means something else when it's on the website. So you have to type it out. You have to type the C and you have to like spell out the word plus plus. Okay.
Okay.
All just put e-calculation PNP divided bias program, then that would be fine. Don't put the C++.
Got it. Okay.
Yeah, because this is designated as something else. The same thing with other student that put in this designation. I cannot open it because I can click on it and they would give me all the errors. They told me that here's
it errors out because I guess it attempts to execute, or it says, hey, there's code in here that I don't want you to open because it might do something to your machine, right?
No, not necessary, because there's a coding that inside this that is this is a sort of reserved for the computer, and it won't let me open it.
Okay.
Okay.
All right.
So just just put the word program and then .text and then just upload that, and I will be able to.
And sorry, and on the first part that you stated, so the one that I did upload that you were able to verify, that one I did incorrectly or didn't do the right one?
This one was the wrong one. This one was from the handout. Okay, that wasn't from the handout. From the handout here, the e-calculation from the, if you go handout, that was I was looking at the program, and it was based on this Excel here. Let me see. Because I look at the variable, so this was based on this one here.
Okay.
And so the one that is on the website, the one that is supposed to be from the website, the one from the homework is let me see, NPN. The NPN would be this one here.
Okay. So I'll re-upload and I'll modify the one that you
Right.
just...
As you can see, R1 is a different value and R2, RC, and all that. Okay.
All right.
And then your expected value down here that was not matched, and so therefore that was the wrong one. Okay.
All right.
Thank you. Okay, so that's updated for Tech 1 student. Okay, so and then so that's pretty much it. And so that's so far. We got a couple of people that did pass already. So good for you guys. So just keep at it. Like I said, the first 10 of the assignment need to be turned in. So you have during the spring break to work on it and make sure you upload it to the website. If I miss your name and you don't see that I give you credit for it, let me know. And so I can go back and recheck on the website, because you know, I do miss. You may have turned in somewhere else that I can't find it, and so therefore we have to fix that. Okay. All right. Okay. Now
Hey,
for
sorry, I came in.
Go ahead.
Sorry, I didn't mean to cut you off. This file's on the website somewhere? I came in late.
No, this file is not on the website. This is what I retrieved from the server, and just to show that
Okay.
what you have
All right, so I
completed
look
up
like I'm
so
good.
far. Yes.
Perfect.
So
Thank
for
you.
Nicholas, yeah, you did well, pretty well. You got up to assignment 10 already turned in. So the
Yeah.
next set of 10 will be due at the end of April. Okay.
Okay.
So
You mentioned spring break. There's a spring break with this program?
yeah. So if you look at you can go in here, go into the website, and you click on calendar.
Yeah.
And you will see the calendar right here. It says spring
Sweet.
break, the 28, 29, 30, 31.
Okay.
And all the way to the 1st. And then, so
Okay.
yeah, you're going to have 1 week off.
Sweet.
Okay.
Hey, can I ask a question about from homework?
Sure. Let me go ahead and share this
Sure.
tech 2, and then we'll go over the homework.
Okay, thank you. I appreciate it, Sam.
Okay.
Hi,
Thank you,
Sam.
Nicholas.
Before you go to tech two, can you go a little down so I can see what I have?
Okay, Luis. Let me see. Okay, Vargas. Okay, so you got this here. Okay, so we got you have up to assignment 11, and then you pass the NPN divider software,
Thanks.
the e-calculation.
What's the percentage that I have in total?
Excuse me?
Like the grade I have?
No, we don't give you grade. We either you turn in a passing assignment or you didn't turn in a passing assignment.
Got it.
Okay, and then at the end, then at the end, we're just at the end. Remember, this class is pass or no pass. Okay. So
Oh,
there's
okay.
no,
Thank
yeah,
you.
there's no, you won't see any grade that designated to you. Either you turn in assignment, you get credit for it, or you don't turn it, you don't turn assignment, you don't get credit for it. Just like here, those are not getting credit for because those weren't turned in yet. Okay.
Hey, Sam, I got one more question on assignments.
Go ahead, Nicholas.
You said I have up to assignment 10 on there. I turned in 11, 12, and 13 last night. Did you just haven't updated it from last
This
night?
one was, I checked it today. It's at 2 p.m.
Huh.
Okay, so
Okay.
that was updated since 2 p.m. So if you turn in a little bit after 2 p.m., I have not had a
Yeah, I
chance
turned them
to
in
look at
last
it.
night. And that's
Okay.
up to assignment number 10 from the way you guys number it on the website or
Okay.
on the homepage.
Okay, Nicholas, I
Yeah.
will take a look at it, make sure.
Okay.
So
All
I
right.
made
Thank you.
noted. Okay, Gibbs. Okay.
Yeah, I turned in 11, 12, and 13. I just have some questions on 14. I didn't turn that in yet.
Okay, 12,
All right,
13,
thank you.
and 14. Okay, I would definitely spend some time to check that, make sure it's
right.
it's on the server. Thank you. Okay, for Tech 2 student, this is what I have for you guys. Now, so far, I only do mainly Mr. Pham asked me to mainly check your software to make sure that it's working. Okay, so as of right now, these are the people that I have that turn in that I was able to find under Tech 2 turn in, and so we got a couple of people that have not turned in there. So as you can see, so if it's good, then I put a pass. If not, then it's a whatever the test that failed for Jennifer. It looked like you passed on DLab 2, you fell on test 5. So make sure you fix that and re-upload it to the website. Okay. And for Billy Rojas, look like your DLab 1, there's no software. I see you turn in the Excel, but it doesn't have a software onto there. So I can't do nothing with that DLab 1. Okay. Joe, look like you're doing pretty good. And so DLab 1, DLab 2, DLab 3, and DLab 4, you fell on test 7.
I'll check that out.
Okay. All right. For Emily, you got DLab 1, good. DLab 2, now that was like I already sent you on the chat, so it fell on test 5. So just take a look at that and look at your software and look at what you have from the answer port A and port C for that and fix that software. Okay.
All right, I will. Thanks, Sam.
Okay. You're welcome.
Mr.
Okay.
Pham, have you Sam, have you run my DLab 1? It's not in there.
There's so much mistake on there that you need to go spend some more time fixing that.
But it passed in class, like I run it with Mr. Pham.
Yes, do you want me to go over that, or do you want
I believe you, but I'm just wondering because he was there when I did it with him.
Yeah, but you're supposed to turn in your software first for me to check, and then that software is not.
It's fine. I will deal with it tomorrow. Thank you, though.
Okay, all right. Okay, so that's pretty much it from for Tech 2. So if I missed anything, please let me know so I can go back and recheck it. Okay, so if you think that I missed something, let me know. Okay. All right, so that's for Tech 2. Okay, we'll go back to Tech 1. Okay, Nicholas, you said you have a question on homework?
Yeah, homework assignment 14.
Okay.
I need some help on how to use the oscilloscope to measure, especially on measuring VC. And then also kind of how to set up the generator for it properly. I think I set it to 10 millivolts for the peak to peak, but I'm not sure if I set it up right. It's kind of hard to adjust the voltage on that
Okay.
computer. And
Alright.
if you could just run through how to use the generator and then how to measure VC specifically and maybe like VN or V out, so I can see another
Okay.
example.
All
Thank
right,
you.
certainly. Okay, one. Let me go ahead and set that up. Let me see, open up MSIM7. All right, so we're gonna be look at MSIM7. File open. DLab. This one is from the 14. Okay, so share screen. Okay. All right, can you see my Excel and my
Yeah, I can see it. Yeah.
my MSIM7? Okay,
Yep.
so here when you look at the generator, okay, when you click on here, so you can
Yeah.
click on the frequency as well as
Yep.
the amplitude.
Yep.
Now amplitude here, now you can't be able to adjust this. Now you can put zero, the zero on your keyboard, and that would
Okay.
zero out the whole thing. As you can see, I just push 0,
Right.
and then it
So
cleared
now
out.
it's in.
Now I can move this cursor to about right here, and so I
Yeah.
move this pointy arrow. Can you see it?
Okay.
And so I
Yeah.
can move that 1, 2, and that would be
Yep.
around 10 millivolt.
Yep.
Or 0.01 volt peak to peak. So now I press
Yep.
1 on my keyboard, and it
Yep.
changed to 10 millivolt.
Okay.
Okay.
Cool.
So that's how you set it up. And
Now,
then, okay.
Once
and
you
now-
get the 10, do you have to hit enter or something? Because mine just keeps flashing afterwards, and I couldn't figure out if it was
okay,
set
yeah.
right.
So when you click, when you come in here, let me go ahead and sort of delete this and then see re-put
Yeah.
it. Okay, so I put in new generator there so you can see. Okay, so I put a generator here and connect that into circuit.
Yep.
Double. Okay, so now I turn the power on. Okay, so
Yep.
it would show 100. Okay, so now I press, so I just use my hand and go to my keyboard and press 0, and that's 0 out the whole thing.
All right.
And then you want to do is use the this one to move the cursor to the right. So 1, 2, and right there would represent 0.010 volt peak to
Yeah.
peak. That's same thing as 10 millivolts. So I now press 1 on there, and then it just changed automatically.
And do you press enter after that though?
No, I
Like while
don't
it's
press
still
anything. I
flashing?
just push 1, and then it just changed to 10.
Right. And then you just leave it from there.
Yeah, just leave it there. And
Okay.
okay.
I thought it was strange that it's still flashing. I wasn't sure if that was like an entered value, you know?
Yeah, look like it gave me a flash right here. And so I can, like I said, I can move my cursor to a location where I can change it. Now I can turn on this knob here to turn right or left. Okay, so I can start changing. Now I can, okay, so that's as small as it goes. And so I can push in 2 for 2 or change it back to 1. Okay.
All right.
And now it stays at
Cool.
that 1. But yeah, I don't press anything except the number that I want the value for.
Yep.
Okay, and then you can change the frequency, and you can set up the frequency, which is 1 kilohertz. Okay, so the amplitude is there, and now we click on your oscilloscope.
Yeah.
Let me go ahead and sort of move this one aside a little bit. Okay, so we're gonna have the oscilloscope, and okay, we turn the power on. Now you said you want to measure VC and VE.
Yeah, VC mainly.
Okay, VC it would be right here. So C is right here. So we connect this one to the point C. Okay.
Yeah.
And then we just turn on the simulation. Okay. Now I have to do just put the AC signal because we want to look at AC signal. And right now I have DC coupling. So you can press in the 1 here to activate that. So press 1 and then change the coupling to AC.
Okay, that's why it wasn't working. I kept going through this last night and it seemed like an easy thing to measure, but I didn't change the coupling.
Okay, so then you're gonna have to do is just adjust this one to get your signal look a little bit bigger and give it a little bit more. Now you have that. Okay, and then you can do a single to stop it. And then you'll do, and then you can click a quick meter to measure it. Okay, so that's come to about 1.28, 1.29, depending on when the signal stop. So that's 1.28, 1.29. Okay.
All right. I'm still getting a flat line on my oscilloscope.
Okay, let me go ahead and stop sharing, and then you can share your screen.
Well, the thing is I'm not set up on Zoom on my computer. I'm like on my phone.
Oh, okay.
And
Okay.
yeah, I'm like
all right.
doing two different devices here. Sorry.
Okay,
I'll
that's
keep
all right.
working with it.
Okay, like I said, mainly it probably and then just go through and make sure you're when you connect your wire, make sure you put
Yeah.
a little bit further from the lead of the component, because
Oh
if you
yeah,
put it,
that I don't have that done.
yeah, if you put it directly on there, then you it may not, you think that it's connected, but most time it doesn't, it won't connect it for you. You have to physically doing that. You have to connect the wire. So right here.
So are you saying don't have the function generator touching the capacitor?
Yeah, you don't want to put it directly like this.
Okay.
And then
Yeah,
it
I
doesn't
don't-
seem like there. You may think that it's touching, but if you zoom in that location, you can see it, that it's very, very, it's quite a little bit of
Okay.
distance from each
Yeah, I
other.
do have a wire connecting it. So,
Yeah.
but I don't know what else is. I'll work with it. Thank you for your help.
If not, just redraw your circuit. As you can see, there's like a small right here. It seems like a little small gap, but you can't see it. Now I can pull it. Now it's seen, and then it doesn't say, it doesn't have like a wire. So
Sure.
just go and then we can go ahead and then place draw wire. Okay.
Hey, if I just turn the video on my phone's camera, can I show you this screen that I have set up?
I can see it, but it won't be clear when you, unless you share your computer screen, then it will come out clear. But through the phone, because of the way that the light is reflecting off in that into the camera,
it's just not gonna work good.
Yeah, it won't show up really well.
All right,
it's hard
that's fine.
it's difficult to see.
Yeah.
Okay.
All right. Thank you for your help.
Okay, you're welcome.
Just one quick question, Sam.
Yeah, go ahead, Joe.
On the test I failed, is that test clock 7 or test number 7?
Test number 7.
Test number 7. Okay, I'll check it out.
Okay. I believe it was, I think maybe you have your input, your expected data is incorrect or something. I forgot what it was. I know it was, just go look at your input and your output and what your expected data. I think your expected data was incorrect.
Yeah, I got 0x02.
Okay, well, maybe it's, I think it was something else that I did see that it was. So for test, it looked like test on test 7.
Test number 7.
Test number 7.
Not test clock 7.
No, test number 7.
Okay, thank you.
Okay.
I'll check it out and I'll touch bases with you later.
Okay. All right. Any other question, anyone?
Yeah, so can you simply show me the wiring for I think it's assignment 11, the rectifier circuit?
The 11, the Tech 1 assignment 11?
Yeah.
Okay, let me see. Let me pull that up. Okay, so if I open the 11. Okay, let me pull up my Excel.
Yeah, it is assignment 11.
Okay, let me pull that up. Okay, 22, Tech 2, Tech 1, assignment 11. Yeah, so that way when we do through these kind of going through here, everybody get to learn at the same time. And that's what I like about sharing on the Zoom.
It is beautiful.
Yeah. Okay, and then it gets recorded and people can have more time to look at. Okay, let me go ahead and share screen. Share screen. Okay, can you see my
I can
my
see it.
circuit? Yeah. Okay. So now the parts that you're going to need now, the transformer, it's going to be from the virtual transformer. That is from this green one. And I already set it up here. So virtual is virtual transformer. So this one right here, okay, so this symbol here, that's your virtual transformer. And then when double click on that, and then you can change the primary turns primary to secondary. That's 5. Okay, and you click on it. Now it changes to 5. That's what I have here. Okay, and then in order to get this specific bridge rectifier, you want to do is go to now this one had to be specific, so you have to go to the diode here, click on it, you come in here and you want to put the right here FWB. Okay, so that look like the one that I have available right here. Okay, and click on OK to place it. Okay, so that's what I have. It's called so go to the diode FWB, and that's the part number is 1B4B42. That's according to the schematic here. Okay.
Okay. Yep.
All right. Do you want me to go through the which one do you have question on?
Oh, so then when connecting the oscilloscope, could you just show me for any one of the measuring points?
Okay.
I wasn't sure how to get all the readings that are, or the readings that are being asked for.
Okay, so if you wanted to say test point 1 would be here. Okay, so therefore you want to do now on this one here, it's going to be the VRMS, the 120 here. So
okay.
you want to, so you click on that, turn your oscilloscope on. Okay, so now I have to do is let me see if I can shrink this one down a bit. Okay, so now I can put this one somewhere over here. Okay, so now I have to do now I'm going to sort of change my display a little bit to change the background to darker color. Okay, so now say that I need to test point 1, so I connect in this one here, and so we're going to be looking at test point number 1 would be right here. Okay, so now we did, and then this one is going to be we're going to be looking at let me turn this one here, so channel 1, make sure it's AC coupling. Okay, now we can turn on your simulation. Okay, so as you can see, the number is way above that, so and I have to just change it, so this is at 5 volt per division, and my timing is very small, so I need to give it a little bit more. Okay, so now I have to do is just adjust my here and sort of adjust this one a little, give it a little bit more. Okay. Now, okay, so sort of, yeah, that you just play with it.
Okay.
Either compress or stretch your signal, and then this one is a vertically, or you can this one to adjust your time to give you more signal on the display screen.
Got it. Where I was getting tripped up, I was using a different oscilloscope, not this one. I was using the simpler one. But I see
Okay.
Yeah,
Yes.
thank you.
All right, you're welcome. Okay, any other question?
Yes,
No.
Sam, I had a question on that output. I had for the ripple, I wasn't able to get it.
Okay, so you want to, like I said, put on DC coupling, and then we got AC signal, AC. Okay, so we put it there for the signal to do this, to look at the ripple. Okay, and then we turn on the simulation. Okay, as you can see, the ripple is very small here, and so therefore we have to do it, just adjust this until we get more, and there's ripple right there. Okay.
Oh, okay, got it. See it. Thank you.
Yeah, you just have to adjust this because it's so small. When it look like completely flat, you have to adjust a little bit, so that way it give you a little bit bigger signal, and then just adjust this one to stretch it out to look at a little bit more closer. Okay.
Okay, thank you.
All right, you're welcome. Okay,
Hey,
any
Sam,
other
can I
questions?
share my screen to show you where I'm at with assignment 12 or 14? I'm still
Okay, go ahead, Nicholas.
All right. Okay, can you see it?
Yes, I can see I can see it.
Okay, so I got the circuit set up. I'll show you the generator real quick. So I think it's all set right.
Okay,
And
looks
then
pretty.
oscilloscope. Here's my scope.
Mhm.
Let me turn it on.
Okay.
And see, I just have this flat line here. Do you see what's wrong in the circuit or what I'm doing wrong here?
Okay, so let me see. We got the 10 volt that is going in there. That is going to go there. The power supply. Okay, let me look at this. Is the lab 14. Okay, let me look at the circuit real quick.
Sure.
Okay, yeah, your VEE is your VEE should be the negative. It should be pointing to the top. Can you see it on the bottom? Your VEE.
Yeah,
The
oh, that should
negative,
be a
yeah.
-6.
No, -6.
Yeah, no, you want to
Okay.
do is go ahead and remove the wire there, and you have to rotate that. So you have to remove that wire right there in that location at VEE. Go ahead and disconnect all those wires that is connected
Between
to
the
it.
ground.
Yeah, between the
Yeah.
ground and that component.
Okay.
And then, yeah, and then after that, we have to rotate it, that component. Okay.
Okay.
Okay, now we. Yeah, well, that still has the wire connected on the top part. The top part, you have to disconnect the wire, all the wire that connect to the component. Yeah. Okay. Now you can go ahead and rotate it. Control R. Yeah. One more time.
Okay.
Okay. Now we got the right. Now we have the
Okay.
right. Yeah, that's just a bias circuit, and if that is not
I
correct,
didn't
then-
notice that. Okay.
Yes. Okay. There it is.
Okay, now
Okay.
is that right?
A little bit. I think you may have got too many points, like where the C is at. You got way too many of those points connecting. So
Yeah.
make sure you disconnect that and reconnect it with, unless we can't see if it's connected or not. Sometimes it's disconnected
Yeah.
and we can't see it. Okay.
Yeah, things got a little messy there, huh?
Yeah, when you have too many test point, you just almost like
Yeah.
you work in lab volt, right? Lab volt only give you a certain amount of test point. So you can
Yeah.
only put your probe only that one location. You can't put any more than that.
Okay, so I still have this weird signal. Do you think it's because there's other test points here? Or?
Yeah, you may be, yeah, there's something that is not connected correctly. And like I said, best thing is go ahead and restart from the beginning.
Okay.
So
Alright.
just kind of ignore this, just open a brand new sheet and then
All right.
go from there. And that will,
All right.
and to
And then
find out the problem, it's going to take a little bit more longer because we
Sure.
have to erase a lot of these wire and reconnect them. And okay.
Okay. So
All
the
right.
key is kind of keep it clean while I'm going through and testing.
Yeah, just minimize the amount of
Yeah.
points that you have to make
And I'm
connections.
supposed to use AC coupling for this, right?
Yeah, you want to stay with AC coupling because we do AC signal that coming through. Okay. Okay, thank you, Nicholas. Okay, anybody else have any question or any concern about the homework?
No, tomorrow.
Okay, sounds good. Okay, back to you, Mr. Pham. Thank you.
Okay, thank you, Sam. Okay, so make sure you know we don't have a class next week.
Yeah.
So whole week off. That for spring break. The other thing I want to mention everyone to understand in order to get the complete certificate, we need you to get the lecture like the quiz, the lab, the quiz, the test, the assignment to be done. Okay? And also, you must be done for the lab. They can be lab volt and also for the lab intellectual. At this time, basically we cannot based on the hours in order to decide complete or not complete. The reason is in the past, total the hour for student around 540 hours for one semester. However, after start from 2020, I cannot control the hour. That means city just given to you. For example, one semester now they get 252 hours. So if we base on the hour, can take you at least 2 years to complete the program. That doesn't make sense to me. And also that also telling you, you cannot bring the hour to talk to me. You say you get 450 hours complete for the lab. No, I don't care. Really what we do care is it you done for your lab votes. The thing is, everything you're working in the lab is recorded in the server. So we know which one you done, which one you not done. If you done, then okay. If you're not done, maybe you have to stay for a year, 2 years or more, doesn't matter to me. We want the job to be done. We not count on the hours. So don't bring any hour in order to talk to me. The lab contact you, same thing. Maybe you get a D-Lab one up to 13 or 14, I don't know exactly. However, only thing we want it done. And I get one student try to asking about the hour in the lab right now. You understand the lab right now, we get Tuesday, Wednesday, and Thursday, 3 days a week. From 3 to 7. Before we get the hour more than only 3 days. And more than only 4 hours a week. However, at this time, one of the instructor in the program teaching hour reduce it. So that's why only thing that we can do. And when you, at this time, when you're coming in the class, we just want you to sign, not the hour. Someone asking time in or time out, no. When you sign, that the only thing is CD1 to verify you already qualify for vaccination. That's it. That means if you not get a vaccination, we're not allowed you to get into the lab. That's only way. So that's why you just sign and you don't care. Okay? Time in or time out. The thing is we not count any hour. Only thing is we want you to get your job done. And also we get a to sit from 3 to 5, 5 to 7. I already talked to the lab instructor, okay? If you coming in 3, you're working up to 5, and now the next student not show up, you still can keep going, do it. Try to get as much as you think, okay? So hopefully that can be clear to every student in the program. If you get any question, just go ahead and ask. The thing is that what I already explained to you guys in the Zoom for a while, okay? Make sure everyone know the way the program right now running until we go back to normal. Okay, any question, anything? Okay, if it's not, so let me get into my iPad. Okay, so today we try to get few things done, okay? First thing, we're talking about a decibel. It's not too long, but we need that. If you have any questions, just stop me, okay? Let me know. So the decibel unit is important in the amplifier measurement. The decibel is measurement of the ratio of one power to another, or one voltage to another, also in one current to the other. And power gain is expressed in decibel. A, you get a A, is the gain. B means the power gain in decibel. The formula will be 10 times of the log of the AP gain. And the voltage gain in dB will be AV dB, 20 times log of the voltage gain. Voltage gain means VL divided to VE. Power gain is PL divided to PE. And the current gain, the formula, same thing, like the voltage gain. That means AI dB equal 20 log of AI. 0 dB reference. The maximum gain equal mid-range. Mid-range gain and is assigned to be 0 dB value. And another thing, they're talking about the critical frequency. Okay, so make sure you understand what is the critical frequency. Also, they can be cut-off frequency, the same thing, corner frequency or break frequency. That means they get too many different ways to talking about critical frequency. Okay, what is critical frequency? At this frequency, output power drop to 1/2 of mid-range, okay, for the power. So AP in the decibel will be equal minus 3 dB. Also, at the critical frequency, the output voltage is 70.7% of its mid-range. Okay, you understand a mid-range, they get the full. Okay, normally the gain at the mid-range for the voltage V out equal VE. Okay, that means the gain equal 1. AV in dB in a critical will be 20 times log of 0.707, and that will be equal minus 3 dB. So when they're talking about minus 3 dB, that means they're going down 3 dB. However, you cannot do anything with minus 3 dB. And you have to know what that equivalent number for minus 3 dB. That will be 0.707 dBm, power measurement. A unit that is often in measuring power is dBm. Okay, now you then say at this time, if you're working on the radio frequency in the RF lab, when you measuring the power and the unit will be dBm. In the lab, you get a dBm. However, outside the lab, we're not using dBm. When you're talking about the power, they're talking about watt, milliwatt, or kilowatt. Okay? So they get the thing is related between dBm and watt. Now they see the term dBm means decibel reference to 1 milliwatt. Okay? When dBm is used, all power measurements are relative to the reference level of 1 milliwatt. Okay? So basically, the formula for dBm will be dBm equal 10 times for log of the power divided 1 milliwatt. That's the formula. Okay? Now, example, 30 dBm equal to how many watt? Again, I want to make sure you understand. When you're working in the lab system, you get a unit in dBm. However, basically, people don't care about the dBm. They care about watt, milliwatt, kilowatt. So that's why you get a problem made. If you get a 30 dBm, so they want to know equivalent to how many watt. And this is the way we do calculation. dBm equal 10 times log power divide 1 milliwatt. And that is they give it to you the equal 30 dBm. Okay? So now you take the log of P over 1 milliwatt equal 30 divided to 10. You get 3. Now you take the log out. Okay? You take the log out, you get P divide 1 milliwatt equal, okay, 3 to the power 10. This is log 10, okay? 10 to the power of 3. You get 1,000. Then you can calculate, you get P equal 1 watt. Get working on the time, and you have to do on the time either. Do you get any question on that? On that example? Make sure you know how to solve the problem if they given you dBm and they asking you watt or milliwatt or kilowatt. Okay. Second one, example. They want you to add 1 dBm to 1 dBm. Okay, first thing I can tell, you cannot adding dBm to dBm. Cannot. So what you can do? 10 dBm to watt or milliwatt, then add it. Okay? And after you add it, you have to go back with the dBm. And now you see how they did it. Okay? Cannot add dBm to dBm. Merge 10 to watt or milliwatt, then add. When it's done, convert it back to the dBm. Okay? So now, dBm 10 times log of P1 divide 1 milliwatt. And that equals 1 dBm. Therefore, you take the log equal log of P1 over 1 milliwatt equal 1 divided 10 to get 0.1. Okay, take the log out. You get P1 over 1 milliwatt equal 10 to the power of 0.1. Okay, then you get P1 equal 1.26 milliwatt. And the second one here, do the same calculation. You can get the same 1.26 milliwatt. Now adding 1.26 milliwatt to 1.26 milliwatt, you get 2.52 milliwatt. Okay. Now you have to converting back 2.52 milliwatt to the dBm. So you can see dBm 10 times log of 2.52 milliwatt divide 1 milliwatt, you get 4.01 dBm. Okay. And also they're telling you, you cannot add dB watt to dB watt or dB volt to dB volt. Merge 10 to watt or voltage when adding and convert back to dB watt or dB volt. The way it's working will be the same, only the difference they given to you. The formula dB watt equal what? Right here. dB watt equal 10 times of log of the power P divided to 1 watt. dB volt equal 20 log of the volt divided to 1 volt. That's the formula you need when you're working with dB watt or dB volt. So in here we get dBm, dB watt, and dB volt. They get a different formula. Okay. Okay, any question up to this point? Nothing. Okay, a data sheet says that the output of an amplifier 24 dBm. What is the output power? I believe on this one, you following the example, you're able to do it quickly, okay? Like I said, dBm equal 10 times log of P divide 1 milliwatt. That's the formula. And that equal 24 dBm. Okay? And now you can get only log over of P over 1 milliwatt equal 24 divide 10. Okay, you get 2.4. Remove the log, take the log out. You get P over 1 milliwatt equal that 10 to the power 2.4. Okay, so you can get to 51.2, and that will be calculated. You get P equal 1 milliwatt times 251.2. You get 251.2 milliwatt. Okay, also they can tell you anti-log is the base 10 raised to the dB over 10 power. Let's see, a data sheet say that the output of amplifier 10 dBm. What is the output power?
10
It can be
milliwatt.
10 milliwatt, 20 milliwatt. Okay, this one need to correct that right here. 10 milliwatt. Okay, and C. Okay, 1 milliwatt. Which one?
A, 10 milliwatts.
Okay, someone get A. I need someone else telling me so we can go. Make sure you're able to get the answer 10 or 20 or 1 or none of the above. So one and student, let me know that will correction will be A. Is it right?
That is correct.
Okay, so that is the correct. Okay. Now see what happened here. Okay, now you get a true gain. A of the V1, A of the V2. You get the input V in here. Okay, and this is the output. So that's what they're talking about, cascaded amplifier. So if you get to gain 1A, 1A2, okay? If you want to calculate the total gain, if the numerical, you have to using the formula. Total gain equal AV1 times AV2. However, if you want to calculate the dB, decibel, then the formula will be AV dB equal AV1 plus AV2. Okay? So not multiply, they have to be added. Just the formula. And now you get the impedance. You can see that your amplifier here. You're looking into the input that you get a resistance. Okay, that's what they call input impedance. At the output, when you're looking into the amplifier, you see any resistance inside here. That's what they call RO or output impedance. Okay, so on the resistance should the same. RG equal R in equal R out equal RL. That means they have to be the same. Okay, impedance R in microwave system 50 ohm. Impedance R in the TV, in your TV, they can be a 75 ohm or they can be a 300 ohm. Impedance R in the telephone system is 600 ohm. So that they already fit the value. So you can see you connect in, your TV and the cable, they will be 75 ohm or 300 ohm. The thing is they will be matching impedance, so you don't get lost the signal. At a hyper frequency microwave, the dB watt is the usually unit used, where the reference is 0 dB watt is 1 watt. dB volt reference to 1 volt. Okay, so they repeat the formula for you. dB watt equal 10 times of log of power equal 1 watt. dB volt equal 20 times log of voltage divide 1 volt. Okay. Example for the amplifier. So, okay, this is the amplifier right here. Output 200 watt, input 2 watt. Power gain 10 times log of 200 watt divide 2 watt, you get a 20 dB. Output power, okay, you can take 10 times of log of 200 watt divide 1 milliwatt. That given to you 53 dBm. Output power dB watt, then using formula 10 times of log of 200 watt divide 1 watt, you get 23 dB watt. Okay. Also, they given to you the formula. If you want to calculate the power, you know we get a 3 formula. One formula will be power equal R times I square, or P equal V square over R. Okay. Either input or output formula will be the same. Make sure you know you get 3 formula to calculate the power. P equal RI square, or P equal V square over R. Okay. Now, an amplifier has an input 3 millivolt, an output of 5 volt. What is the gain in the decibel? Okay, in here they already got the solution. I just quickly go through that, make sure you're able to follow it. V in 3 millivolt, V out 5 volt. Now you got to calculate the gain. The gain equal V out divided to V in. However, they must be the same unit. You can take the voltage divided to millivolt. No, they have to be the same. So that's why you get a 5 volt divided to 3 millivolt, converting to the voltage, it will be 0.003 volt. You get 1666.7. Okay. And now you take the gain of the voltage in dB. Formula will be 20 times log of V out divided to V in. That is 1666.7. Okay. And finally, you get 64.4 dB. That is the first example. Any question on that? Okay. Number 2. A filter head and power input 50 milliwatt, output 2 milliwatt. What is the gain or attenuation in dB? Okay. Now they calculate P in 50 milliwatt. P out 2 milliwatt. AP gain equal P out divide to P in. 2 milliwatt divide 50 milliwatt. You get 0.04. Okay. And now you want it in dB. AP dB 10 times log P out divide to P in. So that will be 10 times log 0.04. That given to you minus 13.98 dB. Okay. And number 3, a power amplifier with a 40 dB gate has an output power of 100 watt. What is the input power? Solution. AP equal P out divide to P in. Okay, that given to you 40 dB. If the P out equal 100 watt, question is what is the P in? So you take AP dB, 10 times log P out divide to P in equal 40. Get the log only. P out divide P in equal 40 divide 10. You get 4. Take the log out. P out divide P in. You get 10 to the power of 4. You get 10,000. Therefore, P in equal P out divide 10,000. You get 10 milliwatt. Okay? You get any question with that? If it's not, do it for me number 4, number 5. Quickly, to see you can get the right answer like I gave it to you. Number 4, an amplifier has a gain 60 dB. If the input voltage 50 microvolt, what is the output voltage? Okay, go ahead and quickly. We need to someone to verify the answer right or wrong for both number 4 and number 5 before we can moving on. Normally in this kind of problem, you must be now doing right away without looking into the formula or anything else. The thing is that when you apply for the technician, they asking you. Okay, any question? And you get the number 4, 50 millivolt, right or wrong?
That's correct. Right?
Right?
Yes, sir.
Okay, thank you. Number 5, 36.99 dBm.
Watts. 5.
Okay, good. That's also the right answer. Okay. The thing is you'll be in the room like in the class, you have to active, do anything need to do. Okay. Okay, now we get a review here. What is the power level of 0 dBm? By the definition, we already know. 0 dBm equal 1 milliwatt. Okay. And then number 7, they want to add in 20 dB watt to 20 dB watt. I just make sure you understand. You cannot add in dB watt to dB watt. You have to converting dB watt to watt or milliwatt. Then you add it. And after you adding, you get dB watt, you have to converting back to the dB watt. That's the way it's supposed to do. If you get the answer for number 7, let me know. So I can let the student know, so when they try to do it, they know what the answer is supposed to be. For 7, A or B or C or D.
Do you want the answer to those, or
Which one?
the answer should be A for 23 dBW?
Okay, so you get the answer will be A. Okay, number 8. Power amplified with 10 dB gain. And they have the input power of 0.5 watt. What is the output power? A or B or C or D?
Go ahead, Joe, your turn. Kumi, go ahead.
B, 5 watt.
Very good.
Which one?
B,
B.
Oh,
Kuma, right?
yes.
yes.
Am I correct? Yeah.
Very good.
Thank you.
Number 9. What I said is, you guys been in the program from 2020. Someone, okay, 19. Long time, 2 years, more than 2 years. I could believe it, but I cannot do. I cannot do anything. You see that? Whatever they want me to do, I just go ahead and follow at this time. Cannot do anything else. However, for this type of the question, I mentioned to you, you must be doing quickly right away. If you apply technician job, you must be take the test, and that's what they asking. Okay, number 9. Amplify 20 dB, gain, output of 10 volt. What is the input voltage?
B.
1 volt.
Very good.
One.
Excellent.
You say B, boy?
Yes.
Boy, one. Yes, sir.
Yeah.
Very good.
Thank you.
Why I just gave it over and over and over? What I'm saying is, you in the future will be hitting to that. I want you to get it right correction. Okay, number 10, 20 dBm equal how
27.
many watt?
27. 7.
5. 0.5.
Very good.
You say 0.5.
Yes. Yeah.
Very good.
Okay, I'm waiting for Sam. I'm not doing calculation.
Yeah, it's 0.5 is correct.
Yes.
Cool me.
Yes.
You're getting good.
Thank you.
Where's Mrs. Smith?
So, Mr. Smith.
You get the
Okay.
last one.
Yes, I give to him the last one.
Come on, Joe. You got the last one. Where are you?
I'm eating, have Tech One do it.
Okay.
You are Tech 3 now, right?
No,
No, this one is
2 watts.
That's correct.
What number?
2
11.
watts.
5 watt, right?
2.
No, number 11 is 2 watts.
2 watt. Okay, let me do it.
It's 1.995. So round it up to 2.
Yes, yes.
Okay.
Thank you.
That's it. So not much in the dBm, but a lot of work in the dBm. You will see later. Okay.
Mr. Pham, could you go back to get a screenshot on those answers, please? All right, thank you.
You're welcome. Okay, now we will be go into the next one. Differential amplifier.
Sam, question? Sam?
Yeah, go ahead, Lo. Sorry.
I was just wondering, when you did the 1.99, were you using rapid tables, or that's just calculation?
That's just calculation.
Right.
You
Yeah.
can use the table. Yeah, you can use the table, but if you can do the calculation, if you have a calculator, it would be very easy. If you use Excel to do the calculation, it's even easier.
Yeah, I was looking at rapid tables.
Okay.
I was cheating.
Oh, okay.
Okay, now we go next will be a differential amplifier. A differential amplifier is a bipolar junction transistor amplifier. That's only telling you inside. This is a symbol and this is a circuitry. Okay, inside that symbol for the amplifier. So a differential amplifier, bipolar junction transistor amplifier that produce output data function of the difference between two input voltage. So when you get an input voltage 1 and 2, that's what we call talking about differential. Okay. And now inside that symbol is this circuitry here. They're using the Q1, Q2. They must be matching, identical. Okay. RC1, RC2, also the same value, exactly the same. Okay. Now, you get a one output here and another one output here. That means you get two output. So, in order to understand, basically, on this circuitry, you already know the bipolar transistor. In a bipolar transistor, last time we already talking, they get a common emitter. And that's what happened for common emitter. That will be telling you input output will be 180 degrees out phase. That means they opposite. Second one, you common collector. Okay? Input output will be in phase. And the last one, common base. You can get an input output will be in phase. Okay? So now, if you're looking at the circuitry Q1, I want to know what the configuration for this amplifier. Common emitter, common collector, or common base. Which one?
Common emitter.
Common emitter. Okay? If you're going back to the common emitter and you understand the input applied to the base, output from collector. Okay? And input output will be our phase. That means if you get the input here, then the output here will be opposite. Okay? Now, at the input, you get a sine wave, and in here, also you get the sine wave. So, what the configuration for Q2?
Common emitter.
Come on. If you're looking into the display, the sine wave applied to where? For Q2.
It's a common base.
Exactly. If you try to memorize common base, input applied to emitter and output from collector. And the common base input output will be in phase. That means at the output here, you can get sine wave. Same thing. Okay, not opposite. That only thing is when you're looking into the circuitry, you know this is a differential amplifier. And Q1 will be common emitter. And Q2 will be common base. That's only thing we want you to know. Now, let's see what they try to do. Assume both transistors are identical. RC1 equal RC2, IE1. That means emitter of Q1 equal IE2. Emitter of Q2 will be the same. And they will be equal I times RE, IRE, times RE. Okay, IRE equal VE minus VEE divided to RE. Okay, and the current IRE, they call a tail current. Okay, and also they given to you VC1 equal VC2, okay? Equal VCC minus ICRC. That means in bipolar, we already calculated, and VE equal VB minus 0.7. Okay, now see what happened. On this circuitry of the differential amplifier, they connect the base of Q1 to ground and the base of Q2 to ground. Okay, that means both input grounded. So they measure the voltage VC1 and the voltage VC2. You can see they will be equal in the meter. Okay, that's how they show for this configuration. Okay. Okay, now the difference here. They will be applied to the base of Q1. However, Q2 at the base will be rounded. And they connect the meter. Okay, so you can get a VC1 smaller than VC2. For this configuration, sideway connect to VB1. Q1 is CE amplifier. Input and output Q1 is inverted. Okay, that we already know. The thing is Q1 is CE amplifier. Okay. For this configuration, VB2 is round. Q2 is CB amplifier. Input output will be in phase. We already talking to you. Now on this one, now they apply the input to Q2 and the input Q1 will be rounded. Just opposite on the one we just learned it. Okay. For this configuration, sideway connect to VB2. So that's why Q2 is CE amplifier. Input output Q2 is inverted. Okay. And the VB1 now will be rounded. Okay, Q1 is a CB amplifier. And input output of Q1 is in phase. Okay, we already know that thing. Okay, now you can see you apply the sideway into Q input of Q1. So that's why you can get the output of the Q1 will be output here. You see that inverted CE amplifier. However, Q2 will be CB amplifier. So that's why the output they will be in phase. You see that? In phase with the signal. Okay. Let's see what happened here. Okay, so basically this is try to explain a little more detail. Okay, you get sideway here, then you get a sideway here. This sideway will be applied to the head meter of Q2. Okay, so now they apply sideway to Q2. And this sideway also go into head meter of Q1. Okay, so head meter Q1 will be CB amplified, Q2 will be CE amplifier. Okay, that will be CB. in phase. That will be CE out of phase. That's why they get a different phase right here. That's a very clear, okay? Now, let's see. Mode of signal operation. Single-ended output, input. What that mean? That means you get a two input. However, they apply a signal to the only one input. The other input will be routed. That's what they call a single-ended input. Okay. When the differential amplifier is operate in a DIT mode, one input is routed and the signal is applied only to the other input. Okay, so you can apply signal to input 1, or you can apply signal to input 2. And if you're looking at the output, you get two outputs, they're the same, but they will be opposite. See that? Differential input, okay? And now you can see they will be applied the signal into two input, okay? The very, very important here, you have to make sure you understand. When you apply input to input 1 and input 2, those signals must be opposite, okay? They must be opposite. That only telling you input positive and the other one have to be negative. They must be, okay? Otherwise, they're not working. That's the only thing, make sure you follow that. Now, on this one, common mode input. Both inputs are the same phase, same frequency, and the same amplitude are applied to the two inputs. That means this one and this one identical to both input. Now, the outputs are superimposed and they are cancelled, resulting in a zero output voltage. That means if they identical, the same output will be zero, nothing. Okay. This action is called common mode rejection. Okay. Common mode rejection means that this unwanted signal. Unwanted signal means the noise, okay, will not appear on the output, the desired signal. Common mode signal noise, okay. General are the result of the pickup radiator energy on the input line from adjacent lines. Okay, this signal is both equal amplitude, frequency, magnitude here. Considered to be the noise. Okay, the noise, that means the unwanted signal. You don't want that signal. Okay, like the radiator from the outlet of the power. So they get the noise. Okay, and they don't want that signal. And they want that to cancel out. You see, common mode rejection ratio, CMRR. The measure of an amplifier's ability to reject common mode signal. A parameter called common mode rejection ratio. The formula will be CMRR equal AV of a differential amplifier divided to ACM. That means the gain of the noise. Okay, where AVD is differential voltage gain and ACM is a common mode gain. The thing is they get the gain, okay, you get the noise. Also, they also get the gain for the noise. That's what they call ACM. The higher CMRR will be the better. The CMRR is often expressed in the decibel in the following formula. CMRR dB, 20 log of AVD divided ACM. Only thing you can make sure you understand what is AVD. That's a differential voltage gain. And ACM, that's basically the common mode gain. Okay, now, example. A differential amplifier has different voltage gain, 2000, and a common mode gain, 0.2. They want the common mode rejection ratio. That just apply to the formula and do calculation. CMRR equal AVD divided ACM. 2000 divided 0.2. You get 10,000. Okay? And CMRR in dB. Then you have using the formula 20 log of 10,000. You get 80 dB. And make sure you understand that you get a higher number for common mode rejection ratio and the better system. Okay. Number B, a differential amplifier has a differential voltage gain. AVD is 85, okay, 0, and a common mode gain of 0.25. They want CMRR and expressed in decibel. We already did it. You take AVD divide ACM, you get 34,000. Then you convert into dB. Okay, common mode rejection in dB 20 log of 34,000. You get 90.6 dB. Okay, any question on that? Okay, if it's not, what else here? Okay, in here they already get a solution for you. Okay, I just quickly go through that. Now, for the differential amplifier circuitry show, single-ended output. Okay, what that means? That means you get a signal right here. Apply only to input one. Input you have a no input. And now they given you another two signal identical right here. So basically this signal is the noise. They affect you input one and also input two. Okay. They given the AVD. That means the gain, differential gain. Okay, 2500. And a common mode ratio, 30,000. V in equal 500 microvolt. VIMS. At the same time, a 1 volt 60 Hz common mode interference signal appear on both input. That means this is a 1 volt right here, 1 volt right here. Okay, 60 Hz. That means from the outlet, they affect to input one, input two. They want to determine the common mode gain, ACM. Okay, so basically you know CMRR equal AVD divided ACM. Okay, then from this formula you can calculate the ACM equal AVD divided CMRR. Okay, you already get 2500 divide 30,000. You get 0.083. And they want expressed in dB. Then that's why you can say CMRR dB 20 log of 30,000, you get 89.5 dB. And they want to know the RMS output. Okay, V at a different equal V1 minus V2. Okay, V1 is 500 microvolt. V2 no, nothing, 0. You get 500 microvolt. So V out equal AV times V in the different. Okay, this is the gain and this is the input. Okay, 2500 times 500 microvolt, you get 1.25 volt IMF. By the way, if they want you to measure the voltage of the signal here, okay, with the oscilloscope, and you can see a big problem here. This signal is 1 volt. This signal is only 500 microvolt. So no way you can see this signal, okay, inside this one. The thing is this one is too big and this one is too small. Okay. So basically this signal, your voice, buried inside this one. So that's why they need a differential amplifier. Okay, differential amplifier try to block this noise, and they amplify only this signal. So this signal can be shown up at the output. Otherwise, no way. Okay, so you can see the big important thing for a differential amplifier. They try to amplify the small signal, will be burying big noise. So that's why sometimes you see the signal, you just see a dark one, just a big signal. You cannot see any small signal inside that.
Mr.
You
Fan,
have to get it go to the differential amplifier.
question.
Yeah.
So if a noise signal had, let's say, 100 different peaks, and each peak was a different frequency of noise, the differential amplifier should be able to pick out only one of those frequency peaks. It's a more of an accurate filter then. Can filter noise for one specific signal.
That's what inside of them, inside a differential amplifier. They have the thing in order to block the noise. When they look at back to the input, they see both inputs the same. They have to be canceled out before they can go out.
So in an FFT, can the differential amplifier, I'm sure it can, be more exact in finding the peak or adjusting?
Now they just try to delete the noise.
Delete all noises and keep one, or delete the one?
Now delete both. The thing that they looking back, they see both signals identical, considered to be a noise. Okay, they're not allowed to go into output.
Yeah, I'll have to look at a simulator. All right, thank you.
Okay, now the thing is when you want to measure using the scope to measure at the input one, you never see the signal. Even you set AC/DC coupling. The thing is both is the AC. Only thing is one will be a big one will be a small one. Okay, so that AC coupling, DC coupling didn't have any. You
Even
want
if,
to see. You want to see the signal. You must be see at the output. The thing is, the output will be blocking the noise. They affect into both input 1 or 2.
can you apply various decibel adjustments to locate that specific frequency? I mean, you're saying you can't necessarily find it once you apply I guess what I'm trying to say is
This one is not you can apply. You see that? This is just a noise.
right.
So if you're looking input 1 on the oscilloscope, you can see the signal, a big one, nothing. You cannot see anything. The thing is your signal right here, burying inside the noise here. So that's why you cannot see. And they want to see, then what can they do? They have to need a differential amplifier. They will be remove that guy here. And they let this going out only. That is the purpose.
And it's more hardware controlled versus software. Then
Nothing to do with software.
you can't refine it then with software.
No,
All right, thank
that's
you.
a hardware.
How about inline oscillators to have to act as filters or act as like use capacitors as a filter? Can capacitors do a separation, more accurate separation?
No, I don't know what inside that.
Well, I'm just, if you wanted to clean a signal up, clean it. Could you put inline capacitors at different times measurements to act
Okay,
like a,
I understand. You said you should connect capacitor here, right?
yeah, actually a few, yes, to try and filter out the noise.
Try to filter out, right?
Correct.
That's not the purpose for the differential amplifier.
The capacitor, doesn't that just block the DC, not the AC?
Yeah, they can sort both to route.
I think the point here is that the noise go through input 1 and input 2, hence they cancel out, and then you end up with 0, and then what's left is just your voice that comes out.
Exactly, that's why. That's
Yeah.
why they need a differential amplifier.
Right. It has to go through import 1 and import 2 so they can cancel out because they're identical.
Right. When they see identical, they will be removed to make it a minimum, not affect into your signal. Okay, that is the purpose.
Thank you.
You're welcome. Okay, this is an example. You see, you get this is common mode, the noise. This is your signal. Now they apply both, not only one. However, pay attention on that one. When you apply input to 1 or and input to 2, they must be opposite. This go up, this going down. Okay? Otherwise, they consider to be the noise. That is a very important. Both input, your input here must be opposite. Okay? For the differential amplifier, so single-ended output. What that mean? Before we draw 2 output here, now they're using only 1 out. That's what they call it, single-ended output. Okay? Given AVD 2500, CMR 30,000, V in 1 equal V in 2, 500 microvolt. I am at the same time, a 1 volt 60 hertz common mode interference signal appear on both input. They want to know that I am at output. Okay, to see how they do. V in equal V in 1 minus V in 2. Okay, so each one is 500. So first one is 500 microvolt minus. The second one have to be opposite to the first one. So that's why they get minus 500 microvolt. Basically, different voltage input will be 1 millivolt VIMF. That's why they're telling you both have to be opposite. If they're not opposite, they cancel out. Okay, so V out equal AVD times V in different, so you can get 2.5 volt IMF. Determine V the IMF interference voltage on the output VIMF output. So that one and that one is interference. Okay, and also they get 1 volt. Okay, so ACM equal V out CM divide V in CM. V out CM equal ACM times V in CM. Okay, so you get a gain, let's see, 0.083. Okay, where we get 0.083. That means the gain of the common mode. Okay, you already get a AV 2500 CMRR here. Then you can calculate the ACM. Okay, that will be 0.083. And you get the input will be 1 volt. So the output, they will be 83 millivolt. So if you calculate the output, you get 2.5 voltage IMF. And also you get a noise. However, the noise now only 83 millivolt. That's a very, very good example to telling you when you apply input to the differential amplifier. Okay, if they given to you the gain of the differential amplifier and the common mode rejection 30,000, you're able to calculate the gain of the ACM. We already know a common mode rejection equal the ratio between AVD divided to ACM. That's it. Okay. The thing I try to finish as much as we can in the April, so we can get a May and June to exercise. Okay, with the quiz and also the test. That we did semester, I'm not giving much the quiz right now. I want to make sure we're able to get through the lecture. Okay. So, any question up to this point? If it's not, okay, then we'll be see you on April 4th. And everyone get a very wonderful for the spring break.
Tech 2 on Friday, right?
Okay.
Thank
So,
you, Mr. Pham.
okay, try to get as much as thing you have to be done. If you not go anywhere.
Mr.
No.
Pham, we got Tech 2 on Friday, right?
Exactly. You still see me on Friday.
Oh, yeah.
Thank you, Mr. Pham.
Okay,
Okay.
again, I already telling you for tech two. If you get questions regarding into the lab, that's what we emphasize. Okay. Just text to me. You want to be in Zoom with me. I help you out quickly.
Thank
Instead,
you, Mr. Pham.
yeah, you do better.
Thank
Okay.
you.
Only thing I want to make sure you can get the lab done quick as much as we can. Okay. Then you guys can get the certificate. For most of the students, for a while, we don't have a time to get into the class. And now is the time. I want to your guys to be complete the program. Okay. I don't know what's going on in the future. They can somewhere, they can something, or they return the class to this program like we did before 2020. Then will be much better. But I don't know. Right now, I just do what CD tell me to do. Have no idea. Okay. So, good night, everyone.
Thank
you, Mr. Pham. Good night.
Good night.
Also, like Mr. Smith was trying to bring up with DLab 3 and DLab 5, they're the same circuit.
Okay, I can stop there. Okay,
No, they're not. Oh, yeah.
I can stop there.
Hey, Mr. Pham, did you hear that?
Yeah, what?
That's
For-
Sam
For
said
Tech,
that-
yeah, for Tech 2, the DLab 3 and DLab 5 is the same circuit.
Is it?
Yeah, it's the same circuit. Let me share the. Let me
Yeah,
share.
you can share.
Okay, here is the DLab 5, and this is DLab 3,
Mhm.
and they're both the same circuit. Here's a PC2, PC2, PC1, PC1, PC3, PC3, and
Okay.
PA01 pre and clock, and
Yeah. If you display both, I can see the same.
yes.
Okay, I take on the lab
5 or 3?
either 3 and 5.
The only difference is actually on the quiz part.
Yeah, just a minor quiz question. That's all. That's it.
Okay, I take
That's
it out.
yeah, that's only minor things. But we want to do is we want to look at your circuit. I think this is more important. This is more important right here. The
Exactly,
circuit.
the circuit have to be different.
Yes.
Okay,
Okay.
I take it out.
Okay.
Sam,
Thank you.
Sam,
Yes.
on the DLab 5 with the new question on there,
Mm-hmm.
can you go to that page?
DLab 5. Okay. Quiz here. Okay.
Now, I noticed when we put the answer is for question 3, 4, 5, 6, and 7,
Mm-hmm.
and you're not supposed to put anything for 1 and 2. Why is that?
You can because you look at this one is clear. So if you clear, this one is going to clear automatically. So this is going to be clear. It's going to be 0.
Right.
And then this one is going to be a 1-1 and then an end clock. So therefore, if it's end clock, it would be trigger. So this one is stays. So you got end clock, and this one is supposed to be operating on a negative clock. Let me see. This is going to be P clock, positive clock.
Mhm.
So is it positive clock? So therefore, this one would be no change. So whatever the value was previously, it stays.
That's what they want you understand.
Yeah, understand the concept. If you input this and then you have what clock, depending on what the priority, what is more important. The most important thing is what is pre and what is clear.
Mhm.
And
Okay.
once those are defined, if it were 0, if it's 0 unclear, then the clear would clear out the output. If it's on pre, then it would put whatever the Q is to high. And then if not, then it goes to 1 and 1. Then it depends on the clock. And if the clock is P clock, then it would take the value of the value D. In this case, it's an end clock, so therefore it cannot take any value, but except the value from the previous output.
So basically, number 2, they only want you to understand the clock for the D trigger they must be positive. When they apply negative clock, nothing can be changed. That's
So-
what they want.
So number 2 and number 7, nothing can be changed.
Well, depending on whatever occur on top here first, and so this one here, so you got
No,
T
no,
clock,
number
so this
seven
is
is-
take 1 here, and so this one here. Now this one is the, now you look at this one, so this one don't care, but
No
it would take
change.
on the value of 1, no change, which is whatever the value of the previous output stays.
Yeah, that's what I meant. It was, he says that the end clock is no change.
Okay, and then when here, when you have the pre, okay, pre is 0, so therefore this one we don't care because when they look at the pre comes,
Output is 1.
this one has high priority, so therefore it just take on 1 automatically, and then clear the same thing, clear what goes into 0. Okay. And this one will be the clock, so this one is set, and therefore when you hit the clock, and it would take the value of D, so the D would be 0. Okay, yes, this one, just make sure you understand how the concept of how this IC works. Okay, so follow this IC. Okay. So pretty much you look at this output, so you have the priorities, you know, either pre, and then you have clear, and then you got the clock, and then if you see the clock, and then whatever the value is D is, it goes into the Q output. Okay, if you don't get a clock, if you don't get a clock, then you don't get in, there won't be any output except whatever the output from previous step. Okay, so we're good.
Hey, just one last thing. So based on what Mr. Pham said, basically we got D labs 1, 2, 3, and 4, and 5, he's going to change it.
Yeah, I will. I will
Okay.
check on that.
Okay, so we got 1, 2, 3, 4, and
I
you'll,
see.
well, yeah, we got 6, but I mean, 5 is the one you're going to change.
Yeah,
Yeah, 5 and 3 is the same one, so therefore we keep the 3, but we have to change the 5.
Exactly.
either one.
Okay, either one, you heard
Now,
him.
Mr. Pham, don't mess us up. We gotta change number 5, Mr. Pham.
Change number 5, please.
Number 5.
That basically accident.
Yeah, that's okay, but change number 5.
Yeah, because most of them already done 1, 2, and 3, so therefore you go ahead and change number 5, and so.
Just give us fast number 5. That's it.
Good job, Kumi. Good job.
Okay, the easy one will be number 6.
Yeah, 6 is very, very easy. Only 8 tests.
And display number 6 to have them quickly.
Yes,
Okay.
please.
Number 6.
The truth table.
Yeah, that
Yes.
only they want you to understand, not simulation.
Yes.
Okay, so number 6, yeah, number 6, hold on, let me pull that up, number 6. So DLab 6, C++, Excel. Okay.
If you know the truth table for the logic gates and you know how to put the zeros and ones in the circuit, you can figure it out that way.
Exactly, it just input, yeah, it's just simple input output, and that's pretty much it. DLab 6, let me see, DLab 6 on Excel. Do you want me to run the program, or do you want to see the
Just
Excel?
display the schematic.
Okay, DLab.
Try to explain to them how to get the truth table.
Yes.
Okay.
Thank you.
Okay, so we're gonna be looking at DLab 6. Okay, so share. Okay, so DLab 6, we're gonna be just going through here, DLab 6.
I have to copy off of Kumi's paper.
I already have the notes. I'm gonna ask tomorrow, but now I don't have to. Hopefully.
So we can minimize that. Okay, so DLab 6 is, so you look at pretty, okay, so this one is, you can look at pretty simple. And so we just look at the, whatever the input and output is. So like Mr. Pham said, let me see, going through, just look at the, so. Okay.
So A is PA1, B is PA2, 3 is CN.
Yeah, so you just look at this one here, you know, It would go from here and it goes here. And so therefore nothing much except PA, it would be your C in that would go into, that would go directly to your C out.
Hey,
and the
Sam,
rest of it-
let's do the one with zeros only. Just
Okay, the
Now
zero,
wait out.
zero.
Okay, we are trying to let you understand. We get the half adder
Mhm.
and the one we get the full adder.
right for it.
Okay, what the difference?
So this is full adders.
Okay, this is a full adder.
Full adder.
But what I'm talking about, you get two different circuitry. One
Yes.
will be half adder and one will be full adder. So what happened to the half adder?
Only, let me see.
It got doubled.
Okay. Go ahead, Joe.
Did it get doubled or like if it's because if you got a full part and you got a half part, the half gets doubled or multiplied times 2 within the system to give you the value for the full adder.
No, try understand what the difference between half adder and full adder.
Half and full.
Okay, now we're talking about half adder.
Okay.
How many input for the half adder?
This and this.
3 input.
Now,
No, this is a full adder. At full
a
adder,
full.
you have 3.
2.
Oh, yeah.
okay, now I can tell you. When you're adding only 2 number,
This and this.
that's what we call a half.
So PA1 and PA2.
Mhm.
That's only 2 input. You're adding A to B.
Mhm.
That's it, nothing else. When you're adding 1, 0, 1 to another 1, 1, 1, and that is circuitry you just added, and you don't have any carry.
Mhm.
However, would you understand that when you're adding number, you get the carry. Now, what is carry? Carry means adding
To the next column.
to the next column. So they're telling you you get a 3 input. Input A, input B, and also the carry, that's what they call a carry in. You carry to the next column, you have to adding again, right?
Mhm.
Okay, so this is a full adder. So now you can moving up to the truth table. Okay, now in the truth table, you get A and adding to B. However, also you have to adding whatever carry to the next column.
Mhm.
That's what they call a carry in.
So 0 plus 0, so you get a sum
Yeah.
of 0. Okay. And sum of 0 doesn't have any carry, so therefore this the out would be just 0.
Okay,
Okay. And now this one, 0 plus 1 would be 1. And so therefore you don't have any carry over to in the next one.
in the next column.
Right. So this one 0 plus 1 plus this one 1 plus 0, that would be 1.
1,
So therefore we don't get any carry over.
so 0.
Right. Now this one we will have a carry over.
It'll be 0 carry 1.
So yeah, so this 1 plus 1 would be 10 or 1 0. So therefore you get a 0 and then
0.
1 would carry over to the next column. Okay,
And 0 and 0 is 0.
correct. 0 plus 0 is
And
0.
then you get left over with a 1.
Mhm.
1 plus 1 is 10, and we carry 1 for the next one, for the next see out.
He's on number 4.
Number
number
4,
four, yes.
number 4. Yeah, 1 plus 1 is gonna be what? It's gonna be a 1 0.
Uh-huh.
So therefore you put 0 here, and the 1 will be carried over to the next.
Okay, 1 carry to see out.
And then number 5 is going to be 0 and 0 is 0.
0, but then you got the C in, that's 1, so therefore it goes into the, it will
Right,
go directly to out.
Okay.
And now you have 6, you have 0, 1.
0
Which is
plus 1, yeah, so that'll be 1, and then 1 plus the 1 plus the, So 1 plus a 1, that would be 0 or 10. And that 1 gets carried over to the.
I don't follow that one. So to me, the 0 and the 1 should have been.
So 1 and 1 and plus the carry over. Okay, carry in. So this one actually goes under into this one.
You're just adding it. 1
Right.
adding to 0 is 1.
And then that would be total of 10 or 1 0. So therefore you put 0 and then the 1 will carry over to.
Okay, let me make sure
So
I got
Sam, if
out.
that's the case, why is it number 5 is not equal to 1?
5 you did. You get a 0 plus a 0.
Why don't you carry the C in?
C in because this one here is I believe when you have a 0 logic at the
And
first.
0 adding 0 to get 0.
Right. Okay.
0 adding to 1. So output will be 1.
Okay. Then on 6.
Not carry.
So at 6, 0 plus
Number 1.
1
Oh,
is
sorry,
1.
sorry. Yeah, that's it. Sorry. I was
Carry
making
will
a
be
mistake.
0.
Yeah, sorry. Thank you, Michael.
All right.
Okay. So yeah, like I said, it's going to be this 0 0 and
Plus
plus,
1
and
is
then
1.
the 1 will be the carry in into it, and so therefore the output will be 1.
Oh, so number 5, that's not a 0 there.
No, it will be 1 and 0. Sorry.
Just repeat how you did the number 5 and number 6.
Okay, so you got a 0 plus 0.
Right.
And then you got the C in. So C in would be going here. That's going to be adding onto that. So now you got a 1.
Okay.
Right. So 0 plus a 0, that would be 0. Then you got the carry in. So now 0 plus 1 be 1.
Okay,
Right. So
now.
output is 1.
Okay, now easy to do. Just add. Okay. 0 adding 0 to get 0. 0 adding to 1.
This one.
Output will be 1.
1.
But
And
you
there's
don't
no-
have any carry anymore.
Yeah, there's no carryover.
Okay.
I'll carry out.
So the output is really like the sum, and the C out is like for carry.
You get carry.
Yeah, carry over like this one right here. You got 1 plus 0 plus 1. So that would be 10. You put a 0 and then that 1 would get carried out. And because we don't have room here, we put 1 0. So therefore they can only occupy one digit at a time. So 0 goes here and then the 1 would be going to get carried out.
Hey, I'm not being rude or nothing, Sam. Hey, Mr. Pham, can you explain number 6 one more time?
Number 6. Okay. Add. Okay. Now adding 1 adding to 0. What you get?
0.
1.
No, 1.
1 adding to 0. You get
No,
1. 1 you adding next 1. The last one.
You
What
get 0. You get 0 carry 1.
0. That means the sum 0. However, you still get carry 1.
Yeah,
Right.
so you get something like this here, okay? So like this here can only occupy one digit. So therefore this one will be 0. And that
0.
1 that we didn't put here, now it's going to get carried out.
Okay, yeah.
Okay, now you see number 7. 0
Number-
adding 1.
Is 1.
1 adding 1.
Is 1 carry 1.
0 and carry 1.
0 carrying 1.
Wait a minute, hold on. 1. Oh, that's a 0. Yeah.
Yeah, like I said, it's going to be this one plus this one, and this one would be 1 0 like that. But then you only can put one digit here, the 0, and therefore the 1 has to go occupy at this
Okay.
carry out.
So for number 7, column A is 0, column B is 1. So 0 and 1 is a 1.
Okay, so this one going to be like 1 1.
No. Well,
Carry
on
over
number
1.
7. On number
Oh,
7.
number 1. Okay, so 0 plus 1, so that would be 1.
1.
And then 1 plus a 1
Is 0.
is 1
Carry
and 0.
Is what?
1 and 0.
1 and 0.
And so therefore we only can put one digit here. So therefore this one 0 and
Carry over.
1 would be carried out.
Okay. Okay. Now it's good.
Well, number 8, it would be 1 1.
Yeah, so 1 1 here. So therefore we put only 1 here and we carry out the other one.
Okay, Sam, one last time on 7. Okay, column A is 0, correct?
Correct.
And column B is 1, correct?
Correct.
We add those together, we get a 1, correct?
Correct. That's a 1.
Okay. And then we add that 1 to the
Plus-
other one,
Mhm.
and that's
That
why.
become 10.
Okay. Okay. Oh, I see. Because now we got
Because we carry over the 1
yeah,
over.
yeah. 0
Okay,
and
10.
then yeah.
And since this only can occupy 1 digit, this one with 0 and the 1 would gets carried out.
Yeah. Because when you get like 1, it's almost like 11.
Mhm.
If you know what I'm talking about.
Yeah.
Yeah.
You got where you're going. I got where you're going. Okay. Okay, so that's how you do it. And then, you know, like Mr. Pham said, try to explain here, just add them all together and whatever the value is, just.
Hey, Sam, let's scroll up just a little bit. Scroll up a little bit.
Hold on.
Scroll up.
Okay. Scroll up to the schematic.
Yeah, and if you're super slow-mo like me, you can put zeros and ones into these things.
Yeah,
look at your truth table for your circuits, and you'll come out with the same answers.
Correct.
That's the long way.
Yeah, you can put a substitute the number in here and do your one step at a time. But like you said, Mr. Pham, you want to make sure you understand how the
That's what I was
full
going to say.
adder and half adders are done, you know. And so that's how you do it. And that's how your calculator is designed. And so,
Yeah.
okay. So Kumi, go ahead and go design your calculator.
Yes, I will tonight.
Okay, just use the full adder. Okay, thank you,
I
Mr.
will
Pham.
upload tonight.
Thank you, Mr. Pham.
But you know, another thing too is look at that truth table and you see a consistency at how the numerals are changing from one row to the next. If you do a comparison, you'll see a pattern there. On the CIN, you got 4 zeros, 4 ones, and if you look at B, you have 0, 0, 1, 1, 0, 0, 1, 1. So there's a pattern there, and then you go next to there to A, it's got a pattern there, consistency. And if you compare your outputs, they're opposite of each other from the top to the bottom. Basically, look at it.
Except for number 8, Lowell.
Right. So what I'm just saying is, overall, once you see a pattern, then you can almost guess what the pattern should be. That's all I'm saying.
Yeah.
You want to turn on your microphone.
Okay. So yeah, pretty much, yeah, once you see that, but you know, like Mr. Pham said, to make sure you understand the concept of, you know, A plus B and then whatever the value is, and then you only can put 1 digit at one location. Therefore, we have to get the other one to be carried out. Since 0 plus 0 plus 0, it's still 0. There's therefore nothing to carry out except the 0. Okay.
Okay, one thing we make sure to don't worry about 4041202101, right?
Right.
That is the truth table. When you design, you know, you get each 3 input, automatically you get that truth table.
Right.
Not why. If you get 4 input, you get 16 combination.
Right.
That's the engineer design. Okay. Only thing that you have to know how you get the output for each combination.
Right.
Okay.
All right. Thanks, Mr. Pham.
Yeah. Good night, everyone.
Thank you.
Good night.
Good night.
Good night.
Thank
Good
you.
night.
Good night.
Good night.